You're going to see a system of equation problem or multiple systems of equation problems on every ACT. And they come in two forms. One, of course, is your straight algebra. They're going to give you the two equations. The other is the word problem. I did the word problem for the purposes of this video. Now, if they happen to give you answer choices with both solutions, x equals 3, y equals 5, you can plug those back into your system and see what works. But in most cases, you're actually going to have to solve because, like the problem below, they're only giving you an answer in terms of one variable. We're only interested in how much a drink costs. They don't say what is a drink and what is popcorn. Can't plug it in. Let's start by making the equation. So if you have trouble with making equations, please check that out in the book, on the videos. That's a really, really, really important skill. It's a key skill, shows up everywhere. Price of a medium popcorn, a large drink is $7.50. Okay. And is an operator that usually means subtract, or excuse me, addition. And we have popcorn plus drink is $7.50. Price of 2 medium popcorns and 1 large drink, 2p, again 1d, is $11.50. Now see, you can tell already the math on this isn't too bad. You could even kind of eyeball it and figure out how much a popcorn costs. Some of you are probably accustomed to getting this far, but you may use x and y. I want to caution you against using x and y ubiquitously, always, especially in word problems. Now, if you have a word problem that there's only one variable, right? You're trying to making it a linear equation and you're trying to figure out how many weeks or whatever, then x is fine because you can't confuse it. But in a system of equations, you've got two possible variables that have distinct meaning. And so I like to use things that are representative. When we have a word problem, x and y are not representative. Then you have to kind of go back and remember, was x popcorn or was x drinks? Think about it. It's a waste of time. And really, frankly, I see people miss these questions all the time because they misattribute their answer for what goes where. Okay. Fundamentally, this is what you have to understand. I have two equations. I have two variables. I can't solve a single equation that has two variables in it. It's just not possible. There's really an infinite number of solutions for just this equation by itself. Right? If I just cover this up, I could say that P is 7.50 and D is 0. I could say that P is 8 and D is negative 50 cents, or is 50 cents, negative 50 cents. They pay you 50 cents if you buy a drink. You know, so on and so forth. I can go on and on and on. Any combination works. It would just be like a zigzag. If popcorn goes up, drinks go down, and vice versa. So basically, this is what you got to know. However many variables you have, that's how many equations you need. 2 variables, 2 equations. We're going to do a second video where I do systems with more than 2 variables, which is a fairly infrequent topic, but it's worth taking a look at. And you'll see that it has to be a little equation, although it'll be very, very simple for each variable. Okay, so there's 2 ways to solve, and I want to go over both ways. My preference is for the first way. That's elimination. In elimination, we want to add or subtract the equations, and I've seen it done both ways. I typically express it as adding, just because I tend to see a lot of sign trouble because people forget to flip every single sign in here. Right. When we add the equations, we have to cancel one of the variables. What that's going to let us do is create a new equation down here that only has one variable in it. That's solvable because it only has one variable. So we need one of these variables to have the same coefficient in front of it, but opposite signs. Now, the easy thing to do is to solve for popcorn because drinks is already 1 and 1. And we could do that, or we can solve for drinks. It doesn't matter. Since I think most people would eliminate drinks here and then come back and find popcorn, let's do that. Now, I'm going to multiply this top equation by -1. That translates into making this a negative P, a negative D, and don't forget this part. This is where people goof up. A negative $7.50. Now, I just add like to like. negative p plus 2p, or you could say 2p minus p, is p. D minus D is 0. 1150 minus 750, or negative 750 plus 1150, is $4. Okay. I know the popcorn is $4. Right. Now I can go back and plug that into either equation and figure out what a drink costs. Now, to make this easier, I may go back to the previous version of this where everything wasn't exactly negative. Remember, I made everything negative, so this becomes positive, this becomes positive, this becomes positive. And I plug in $4 for P plus D, in lowercase d's, $7.50. Subtract $4, a drink is $3.50. Where do I see mistakes? I see a lot of mistakes with the XY thing like I talked about. I also see a lot of mistakes with the halfway answer, especially if you're in a hurry, right? If you get frantic, if you're just kind of a frantic test taker, which, by the way, there's some good stuff in the book on that, so you should check out the strategy section as well as the how to prepare for the ACT. Frantic is no way to take this test. But if you're in a hurry, you can make this mistake too, and you can answer 4, even though 4 is popular. If you have a lot of trouble with that sort of misattribution, you may want to think about underlining or boxing the variable that they're looking for. In this case, it'd be drink. Let's talk about the second way to solve. I like this way less, although I have students who prefer it, infinitely prefer it. I like it less because it tends to, on the ACT, give you fractions, variables and fractions when you do it that way, and I don't like that. I don't like that at all. Then in this case, it won't be a problem. So let's go back to our original equations. P plus D equals 750. 2P plus D is 1150. See what I mean when I said earlier you could eyeball it? The only difference here is one popcorn, so there's a difference. That's a fairly straight. But to substitute, what I need to do is solve one of these equations for one of the variables. Basically rearrange. So I'm going to do this one because this is the simplest one. And I'm going to say, let's solve for D again, because that's what we did last time. Even though it would be quicker to solve for P, it's quicker to substitute in for the one you don't want. Talk about that again in a second. So to rearrange, I'm going to subtract a P. So I'm going to have D equals $7.50 minus a P. Since D is equal to this, I can plug D in here. I can plug in this statement in here. So let's rewrite this equation. 2P plus 750 minus P is equal to 1150. Be careful when you do this. If this was a negative D minus D, I would need to throw this in parentheses. Distribute that negative. But since it's positive, I don't have to do it. If there was a coefficient, I would have to multiply both terms by that coefficient. Okay. Let's just start putting like terms together. 2P minus P is P. Subtract 750 to get to the other side. P equals 4. Same place we were, right? And it should be, right? It should work out the same. Then, of course, plug this back in. 4 plus D is equal to 750, like we just did. Subtract 4. D is equal to $3.50. But what I was saying about solving for the opposite variable is helpful if you're really stuck using substitution or you really want to. When I solve for the opposite variable, I'll basically allow myself to plug in and get the one I want. So I want D. So I want to solve for P here. So I'm going to have P equals $7.50 minus D. Now when I plug in, I remove the P's and I'm just left with D. So I'll have 2. Remember, I have to throw this in a parenthesis. Minus D plus D equals 1150. Distribute my 2, $15 minus 2D plus D equal to 1150. And let's clean it up. Negative 2D plus D is negative D. Positive 15, subtract that. we'll get negative $3.50. Then divide by -1, multiply by -1, however you want to call it, equals 350. So you'd save a step that way. Rearrange for the one you don't want. So in this problem, just to recap, while both methods worked really well, I in general prefer elimination. I think it's cleaner, and you make it impossible for you to end up with fractions. There are a ton of examples in the book, and I really strongly encourage you to go through them because there's some nuances and there's some tricks that'll really help you along that I don't feel like I have time to get into here. I do want to say one thing though. If you end up with a system of equations where, let's say you have a rectangle, right? And this is a common setup for this. I'm not going to work a problem. I just want to show you. You may have an equation that's the perimeter, right? And you're given some sort of perimeter value. You know, let's say it's 50. And then you're given some sort of area value. And let's say it's 100. I think that would actually work out. In this case, I would not be able to use elimination because these are just one term. Length times width. Length times width. I can't separate those out to add and subtract. So I have to use elimination. Excuse me, I have to use substitution here. And the easiest one to substitute into, I would rearrange this one to substitute into that. And that's what I would do. You'll see examples like this in the book. So this is a really important skill. It's the only real key skill in intermediate algebra in that section of the book. Definitely know it because it does show up multiple times in tests. And in fact, stuff that really kind of isn't systems of equations, particularly in geometry, can be solved that way or needs to be solved that way. The second video in this set, the more than two variables, it's good to look at, I think, especially if you have trouble making equations, because it's really good practice.